So in this video, we'll derive equations that could help us calculate the heat, work, the internal energy, and enthalpy of various PV processes in gases. So PV processes are processes that involve changes in the pressure and volume. So they are typically expansion and compression processes. So they are almost exclusive for gases kasi gases lang naman ang sensitive sa changes ng pressure and volume sa inyong system. Unlike liquids and solids na almost incompressible sila. Okay? So before we proceed with the derivations of these parameters, go through muna tayo dun sa decision steps. So for number 1 is the gas, real or ideal. Kapag ideal gas equation, syempre gagamit lang tayo ng P equals nRT over V. Kapag real, we'll have to use either of equations of state na na-discuss natin last time or other equations of state na mas maraming parameters. Okay, so syempre mas complicated yung structures ng real gases kaysa sa ideal gases. So for demonstration purposes, I will use ideal gas equation to derive these quantities right here. Okay, so number 2 is the process reversible or irreversible. So kapag reversible process, alam naman natin na yung external pressure is always equal to the pressure of the gas throughout the process kasi maintained ang mechanical equilibrium. Kapag naman irreversible, meron tayong work na equal sa negative P external times delta V, okay? Or whichever equation can be derived from this. Basta ang alam natin, the external pressure is not equal to the pressure of the gas. Okay? So let's note that the following derivations are applicable only for closed systems. Okay? So since closed ang system natin, yung change in the number of moles natin ay 0. Okay? So kapag closed system, walang change or walang exchange na matter inward or outward na system. Okay? So final decision step, is it isothermal, constant temperature, isobaric, constant pressure, isochoric, constant volume, or adiabatic, an isolated system with no exchange in the heat inward or outward the system. So nagdagdag ko lang dito, isolated systems. Okay? So, end isolated system. So, the following derivations are applicable only for closed systems and isolated systems. Kasi meron tayong case kung saan adiabatic siya. Okay? So, start muna tayo sa number 1. So, let's dig deeper into the decision step number 1. If the gas is real or ideal, ano yung magiging situation? So, if the gas is ideal or real, there will be a difference in the reversible work. For example, the work done by the ideal gas is due to its equation, yung P is equal to nRT over V. Kapag sinubstitute nyo siya dyan, okay, the integral of negative nRT V over V times dV from V1 to V2 will just be equal to negative nRT ln V2 over V1. This is applicable for reversible work na isothermal. Okay, kasi constant yung temperature. Hindi nagbabari yung temperature kapag nagbabari yung volume. Okay? Paano naman kapag van der Waals gas? Again, isothermal pa rin siya kasi hindi magbabago yung temperature dito. Hindi natin siya binabari. Okay? So, the reversible work will just be the integral of this expression from V1 to V2, negative PdV. So, this will be integrated from V1 to V2. Ito yung magiging integral niya. Okay? So, again, this is isothermal. Okay? Kasi constant yung temperature. Okay? So, the next difference will be between the internal energy and enthalpy. So if you look at the total derivatives of du and dH, may makikita tayong parameters dito. This is the Joule free expansion parameter or the pi t. Okay, ito yung pi t. And this is the Joule-Thomson parameter, happy t or the happy t. Dinescribe ko last time. So may mga values to kapag real gases. Kapag ideal gas, 0 sila. Okay? So UVT and happy t are 0 for real gas, for ideal gases. Thus, for ideal gases, delta H is Cp delta T and delta U is Cv delta T. Okay? So, since complicated yung ating mga real gas equations of state, magdudwell muna ako sa mga ideal gas para ma-demonstrate yung mga iba't ibang PV processes. Okay? So, mag-start muna ako sa isothermal process for ideal gases. So, for isothermal process, delta U and delta H are both 0 kasi yung delta T nila ay 0. So, the W is negative nRT ln V2 over V1 pag reversible, negative P external times V2 minus V1 if irreversible. So, since the first law of thermodynamics states that delta U is equal to Q plus W, since delta U is 0 due to the isothermal condition, Q will just be negative W. So, therefore, Q for a reversible process will be positive nRT ln V2 over V1, okay? Or, yung irreversible heat, okay, will be equal to positive P external times delta V kapag irreversible. Okay? So, that would be the heat released or absorbed kapag isothermal. Okay? This one is for reversible, this one is for irreversible process. Okay? So, for letter B, isobaric process, dP equals 0. Delta U is CV delta T since nagbabago dyan ang temperature. Delta H is the heat released at constant pressure, which is equal to QP. This is equal to CP delta T. Work is negative P external times V2 minus V1 since irreversible ang ating isobaric processes. Okay? Constant kasi ang pressure niya, so hindi siya necessarily equal sa gas pressure. Okay? So Q is equal to delta U minus W, meaning this is equal to CV dt according to delta U here, plus P external delta V according to work here. So pwede pa natin itong i-simplify from the ideal gas equation. PV is equal to nRT. So delta PV is equal to delta nRT. Okay? So yung total derivative ng right side will be P delta V plus V delta P. Since this is isobaric, delta P is 0, so this is 0. So for the right side, since the total derivative is RT delta N plus NR delta T, and delta N is 0 since wala naman tayong exchange ng matter inward and outer the system and the system is closed. Okay? RT delta N is 0. So the resulting equation is P delta V is equal to NR delta T. Therefore, kung i-substitute natin to, yung NR delta T dito, okay? So this will be CV delta T plus NR delta T. Or this will be CV plus NR times delta T. Since CV plus NR is equal to CP according to this equation, okay? CP is equal to CV plus NR. Therefore, Q is equal to CP delta T, or the heat at constant pressure, Q sub P, which is equal to delta H. So alam naman natin yon na yung heat at constant pressure is delta H. Okay? So for isobaric processes, the change in the volume is 0, so therefore yung work mo is 0 because PdV, okay, and dV is 0. So delta U is still CV delta T, delta H is CP delta T. Since the first law of thermodynamics states that delta U is equal to Q plus W, and W is equal to 0, so delta U is equal to Q. So therefore, Q is equal to Q sub V, which is equal to CV delta T. The heat at constant volume is delta U. Okay? Finally, for adiabatic processes, dQ equals 0, delta U is CV delta T, delta H is CP delta T, and W is equal to delta U, which is CV delta T. Then, according to the first law of thermodynamics, delta U is Q plus W. This is 0, therefore delta U is equal to W. We cannot use the W is equal to negative nRT, ln V2 over V1 because temperature is varying. Hindi natin ito pwedeng gamitin. We have to use this equation. Okay? So, we have an interesting relationship between delta U and the work. So if we equate du equals W and substitute du with CV dt and W with negative nRT dV over V, okay? So hindi pa naman natin to na-integrate, so pwede pa natin siyang i-substitute na to. Ito yung hindi pwedeng gamitin, yung integrated form. Kasi kapag in-integrate mo siya, ibig sabihin na i-vary mo na siya all throughout the volumes. Kapag na-i-vary mo na siya throughout the volumes, ibig sabihin nagba-vary din yung temperature. Hindi pa yun nangyayari dito. Okay? So, pwede pa natin siyang ilagay dito. Okay? So, by substituting, we have CV dt is equal to negative nRT dV over V. So, kapag in-integrate natin siya both sides, pero bago natin siya integrate, ililipat muna natin yung temperature dito sa kabila. So, magiging CV dt over T is equal to negative nR dV over V. So, if we integrate this from T1 to T2, yung left side, tapos yung right side from V1 to V2, we will get this interesting relationship. CV ln T2 over T1 is equal to negative nR ln V2 over V1. This is an adiabatic relation. So, ibig sabihin, kapag nag-increase yung temperature from T1 to T2 adiabatically, makukuha mo yung equivalent increase in the volume or decrease in the volume adiabatically. Okay? So, kapag adiabatic increase in temperature, nagde-decrease ang volume. Kapag ang gas mo ay nag-expand adiabatically, bumababa yung temperature niya. Kasi wala kang heat transferred or release. Okay? So, this is the equation for the adiabatic relationship in exponential form. Okay? So that is the summary of all the necessary equations for each of the PV processes discussed. Okay? So here we have a sample problem. So in the sample problem, 1 mole of monoatomic ideal gas. Okay? So ang CV nito ay 3 halves NR, while yung CP niya ay 3 halves plus 1 NR, that's 5 halves NR. Okay? So this gas was expanded isothermally and reversibly from 0.5 to 2.5 liters at 298.15 Kelvin. So this is the first step. Then, the gas was compressed adiabatically and reversibly to 1 liter. So ito yung step 2. Finally, the gas was compressed isobarically to 0.5 liters. So ito yung step 3. So calculate the Q, okay, W, delta U, and delta H for each step. So ang una natin gagawin, okay, is to determine the pressure, temperature, volume for each step, okay, or for each state ng ating gas. So ang initial state ng ating gas, meron tayong 0.5 liters, tsaka 298.15, and the gas is 1 mole, so we can calculate the pressure using the PV equals nRT. Okay, so the pressure calculated is 48.930 atmosphere. So after the isothermal expansion, okay, so it was expanded isothermally and reversibly, this is the step 1, the pressure is changed to 9.786. Again, this is calculated using the ideal gas equation, given that the volume V2 is 2.5. The temperature 2 is still 298 kasi hindi nagbago yung temperature, is isothermal, and N is 1 mole. Okay? So the next step was the adiabatic compression. So from 2.5 liters, naging 1 liter na siya. Okay? So we use the adiabatic relationship. Okay? CV ln T3 over T2 equals negative nR ln V3 over V2. So the CV of that monoatomic ideal gas is already given. That's 3 halves nR. Okay? So 3 halves nR ln T3. So ito yung ating i-determine. T2 is 298.15 Kelvin. N is 1 mole. R is 8.314, or just R kasi magka-cancel lang naman yung NR dyan. Okay? V3 is 1 liter, V2 is 2.5 liters. So makukuha nyo dyan yung T3, which is 549.197 Kelvin. Okay? Then, after nyo makuha yung temperature, you use the ideal gas law to determine the pressure, which is 45.065 atmosphere. This is determined again using the ideal gas equation. Okay? Finally, this is an isobaric compression. So the pressure is kept constant. So yung P4 nyo given na, that's 45.065 atmospheres. The volume is 0.5 liters as given in the problem. So you can determine the temperature again using the ideal gas equation given that the number of moles is 1 mole. Okay? So makukuha nyo na lahat ng pressure, volume, and temperature sa bawat state. So from P1 to P4, makukuha nyo na yung pressures and temperatures. Okay? So the next thing to do is to calculate, okay, the Q, the W, delta H, and delta U. So for number 1, isothermal yung process. So yung delta H and delta U nyo ay both 0. Therefore, according to the first law of thermodynamics, Q is equal to negative W, while your W is negative nRT ln V2 over V1. So calculating this, you get W is negative 3989.505438 joules, while you get Q, which is positive 3989.505438 joules. Okay? So for number 2, this is an adiabatic compression. So Q is equal to 0. Delta H is still Cp dt. Okay, so getting the delta H, Cp is 5 halves nR, T3 minus T2. Okay, so the T3 is determined using the adiabatic relationship, 549.197. T2 is 298.15. So T3 minus T2 times 5 halves times 1 mole times 8.314 is 5218.01189.5 joules. Delta U is CV delta T, so 3 halves times 1 mole times 8.314 times T3 minus T2 is 3130.807137 joules, which is also equal to the work done. Okay, so W is equal to delta U if the system is undergoing an adiabatic reversible process. Okay. So lastly, we have the final process, which is isobaric. Okay, so the delta H is equal to the Q, which is Cp delta T. So delta H is 5 halves nR. Okay, 5 halves times 1 mole times 8.314 times the final temperature, which is 274.599. Initial temperature is the T3, 549.197. So we get negative 5707.51943 joules, which is also equal to the heat of the reaction. So heat was released as delta H. Then we calculate delta U, that's CV delta T, 3 halves nR, so 3 halves times 1 mole times R times T4 minus T3, it's negative 3424.511658 joules. So for the W, it's negative P external since the pressure is constant times V4 minus V3. The volume is V3 is equal to 1 liter, V4 is 0.5 liters. So V4 minus V3 times negative P external is 22.5325 liters atmosphere. So this is a weird unit. So all you need to do is to multiply this by the ratios of the gas constants in different units. So, nasa taas yung 8.314 because it's in joules. Tapos, yung 0.082056, siya yung liter atmosphere. Makakancel yung mole Kelvin. And yung liter atmosphere, makakancel dito. So, ang matitira ay joules. So, therefore, the unit will become joules. So, the work done is then 2283.017 joules. Okay? So, for the next videos, we will now determine the concept or explore the concept of entropy. Okay, so see you next video.